Alright guys, here's your review video. Settle in, it's going to be a long one. Skip around as much as you need to, find the problems that you need, watch those. Probably, to be honest with you, 1 and 2 will be the ones you need the most. So I'm going to go very slowly through these two and hope it helps. Hope it helps a lot. So here we go. The first one, I'm basically, remember, I'm going to set up the numerator equal to, actually the whole fraction, I should start up here, equal to a over the first linear factor plus b over the second linear factor. Multiply through by the LCD, which is x minus 3x plus 2. The a is missing the x plus 2. The b is missing the x minus 3. All right, x plus 7 is not going to change the whole way through. I'm going to distribute the a. I'm going to distribute the b. And now what I'm going to do is I'm going to combine the x's. Like those two terms have the x's, so I'm going to pull out the x, have a plus b. I have these two left over, 2a minus 3b. They go together. Now, because there's one x over here, and because there's an equal sign, there must be one x on this side, which means a plus b has to equal 1. Because there's a 7 on the left-hand side, there must be a 7 on the right-hand side, which means a 2a minus 3b has to equal 7. All right, now you got two options here. If you want to take your calculator right now and go RF like we did on Monday, that's a great way to do it. I'm just going to do elimination so you can see. I'm going to multiply the whole top equation by, I don't know why I put 2. I'm going to do it by 3 because the sign's already different. 3 on the b's. 3a plus 3b is 3. And just bring this one over. 2a minus 3b is 7. B's are gone. That's 5a. That's 10, which means a is 2. Now if a is 2, I'm going to plug it back in there at the top and get 2 plus b is 1, which means b's got to be negative 1. So there's my a, there's my b. That's the main thing I need. I'm going to plug them back up here at the top. So my answer would become 2 over x minus 3 plus negative 1 over x plus 2. And there it is. That's the partial fraction decomposition for number 1. All right, let's go to 2. Trying to. There we go. And do the exact same thing. This one's got a quadratic factor. Remember the quadratic, you got to build up to it. So I'm going to put a over 2x minus 1. B over the x minus 2. Sorry, that's a terrible fraction bar. And then c over the x minus 2 squared. All right, now, same deal. I'm going to multiply everything through by the LCD, which is basically going to get rid of the fractions, and I'll do it like this. What is the a missing? Well, the a is missing the x minus 2 squared. Get to the b. What's the b missing? B is missing one of the x minus 2's because it just has one x minus 2, and also the 2x minus 1. The good news is by the time you get to the c, all that's missing is the 2x minus 1. Okay, now this is going to take us another second here. It's going to take a little bit longer than number 1. Sorry about that. I'm going to square, multiply, double, square. This first parentheses, so I get x squared, multiply together, double, and square. That's my first parentheses. The second two right here, I'm doing FOIL. And first is 2x squared. If I do outer and inner, I get negative 5x. If I do last, I get plus 2. And this last one, there's nothing to do there yet. Boom. All right, I'm just going to start putting quotes over here to save a little space and a little bit of time. I'm going to distribute the a all the way through the first parentheses, ax squared minus 4ax plus 4a. I'm going to distribute the b through the second one, 2bx squared minus 5bx plus 2b. And I'm going to distribute the c through the last one, 2cx minus c. And that equals all that stuff over there. And what I got to do next, I've got to group together my common ones. So right here's my x squareds. So my x squareds, I have a and 2b. Let me change colors here. My x's are here and here and here. So I'm going to put the x here, and that's going to give me a negative 4a minus 5b plus 2c. That's the x's. And then all that's left over is that term, and that term. I need to make this a little smaller so I can fit it here. And that's going to be in the parentheses 4a plus 2b minus c. Okay, so my first parentheses, my x squareds. If I look at the left-hand side, there's a 7x squared. So I'm going to say a plus 2b has to equal 7 because there's 7x squareds on the left-hand side. There's got to be 7x squareds on the right-hand side. There's negative 29x's on the left-hand side. So there's got to be negative 29x's on the right-hand side. So I'm going to take my second parentheses and set it equal to negative 29. And last of all, there's a 24 on the right-hand side. So that last parentheses has to equal 24. So I'm going 4a plus 2b minus c equals 24. Now, what I'm going to do right now is I'm going to take my calculator and I'm going to go to RF and find out what my a, b, and c is. R. Okay. So hang on just one second. And when I do that, I get this for my ABC. I got 5, 1, negative 2. It should be negative 2. Negative 2. So I'm just going to put those in where I started, and that's going to be it. I'm going to change color so you can see it. Exactly what the answer is. It's going to be 5 over 2x minus 1 plus 1 over x minus 2 plus negative 2 over x minus 2 squared. I'm going to be honest. That's a doozy. That's very impressive. Go on to the next one. All right, find the vertex, focus, and directrix. This first one's already set up for you. Remember the 4p's got to be on the non-squared side. Here's what I know for sure. The vertex, I need to change colors again. The vertex is 0, 0 because there's no parentheses here. 4p equals 8, which means p is 2. Remember, p means how far away your vertex is from your focus. It helps if you draw a little picture, plus it says draw the graph anyway. Vertex is here. Because the 8 is with the y, that's going to open up because it's positive. The focus is 2 away. It's going to do like that. If the focus is 2 away, that means the focus is at 0, 2. And also the directrix is 2 away. It's down here. And it's 2 away because it's going horizontal. What does y equals? And it's y equals negative 2. All there is to that one. The second one, number 4 here, same deal. The vertex is the opposite of what's inside your parentheses, negative 2, 1. Focus I got to figure out. Directrix I got to figure out. I'm going to do a little graph first because that's going to help me the most. My vertex is negative 2, 1, which is here. Because the 6 is with the y, it's going to open up and down. And because it's negative, it's going to go down. Okay, now also 4p equals negative 6. If I divide by the 4, the p is negative 3 halves, or negative 1.5. So right now I'm up at 1. And if I'm going to go down 1.5, it's going to put me right here at negative 1/2. So my focus is negative 2 and negative 1/2 because I went down 1.5. My directrix, I've got to go up 1.5 from there. I'm at 1 right now. If I go up 1.5 from 1, that puts me at 2.5. So I'm going to say y equals 2.5 if you want to do that. That's fine. Or 5/2. And it's going to go like this with the directrix being, oops, do that the wrong way. Sorry about that. Focus is down here. It's going to go down like this. Did it again. It's going to be down like this. Sorry about that. Blew that one. All right, number 5. Number 5 says find an equation of the parabola having net focus, net directrix. Guys, you need to draw the picture. It's going to be hard to do without the picture. So the focus is negative 2, 3. There's the focus. The directrix is y equals 3. That's a horizontal line going right through here. Now, think about this. The vertex is always halfway between those two. Halfway between positive 3 up here and negative 3 down here is 0, which is right there. And the focus has to be inside, so I know it's going up. Okay, so here's all I have to do. My vertex is at negative 2. Sorry. Vertex is at 0. Golly bum. Vertex is negative 2, 0. Sorry about that. Negative 2, 0. And it's opening up. Because it's opening up, I know my 4p is in front of the y. And I have an x squared, except it's going to be x plus 2 squared to take into account that vertex. All right. P is how far it is from the vertex to the focus. It's 3 away. All right. So I'm going to do 4 times 3, which is 12y. And over here I have x plus 2 squared. Guys, that's your answer right there. All right, now we're going to the circles, which means I'm going to do a lot of square completing. So I'm going to put the x's together on this first one, leave some space, put the y's together. That's my marker keeps running. Put the y's together, leave some space. I have 6 over here. All right, complete the square both times. Half of 6 is 3. If you square 3, that's 9. Add 9 to both sides. If you take half of negative 2, it's negative 1. Square it, that's positive 1. Both sides. One more step. X plus 3 squared. Y minus 1 squared. Over here is 16. Which means the center is the opposite of what's inside. Negative 3 and 1. And the radius is 4. So all you gotta do is center and radius. Let's try one more. Let's go to number 7. Same exact kind of problem. Put your, let's group your x's together. So we're going to x squared minus 6x. Leave space. Group your y's together. Leave space. Move the 16 over. So the 16 becomes negative 16. Complete the square twice again. Half of negative 6 is negative 3. Square it. It's plus 9. Plus 9. Same thing over here. Half of a negative 8 is negative 4. Square it. That's plus 16. We're going plus 16 over here also. Gives me this. Gives me x minus 3 squared. Here it gives me y minus 4 squared. And 9. The center is the opposite of what's inside. Opposite of what's inside. The radius is the square root of the number on the right-hand side, which is 3. Got it. Check out that slide one more time. Yeah, it looks great. All right, let's go to the next. Find the inverse. This is review stuff. Remember the gesture. Find the determinant. Flip it. Put it in the front. Change signs. Sorry, switch places with the first and fourth. Change signs on the second and third. So first thing is do determinant. So multiply that way. It's 15. Multiply that way. That's 2. Subtract. It's 13. Flip the 13. Make it 1/13. Switch places with the 3 and the 5. Change signs on the 2 and the 1. And don't forget to multiply 3 by the 13. It becomes 3/13, 2/13, 1/13, 5/13. Boom. There it is. All right, let's go to number 9. Number 9 says, solve by the method of your choice. Some of you, we're here on Monday, choice might be to do RF now. And I can't show you that on the video, so my choice is always to do elimination. So I'm going to take the first one, first equation, multiply it by, let's say negative 2, which is going to give me a negative 6x, a positive 10y, and a positive 22. I'm going to multiply the second equation by a positive 5, which will give me a 35x, a negative 10y, and a 65. Add your equations together, it gives you 29x over there. Here will give me 87. Lucky for us, 29 goes into 87 3 times, so x is 3. Once you get your x, plug it in somewhere. I like this equation, looks like the smallest thing to me. So if I do 3 times 3, that's 9. Minus 5y equals negative 11. Move the 9 over there. Gives me negative 20. Divide by the negative 5, that's 4. So my answer, 3, 4. That's elimination. You could do substitution. You could do Kramer's rule. You could do augmented matrices. You could do RF on your calculator. You know, by now, that's completely up to you. All right, solve this big old thing right here. And I'll give you a hint. I would make sure I could do this problem right here. I would definitely make sure. So, can't find the same base. When you can't find the same base, you got to log both sides. The exponent goes in the front, so I'm putting the x minus 2 in the front. I'm going to do natural log to keep it short. You can use LOG, it does not matter. Exponent in front, natural log 4. When you have two numbers in your exponents, you got to distribute. So I'm distributing x natural log 5 minus 2 natural log 5. Over here, 1 natural log 4 minus x natural log 4. Okay, once you distribute, you got to get your x's together. And you got to get the terms together that do not have x's. So basically that term and that term are switching sides. So that gives me this x natural log 5 plus natural log 4. And over here, natural log 4 minus 2 natural log 5. Now really watch what I do here. Sorry, I forgot the x on this. There's an x right there. To get the x isolated, you got to factor it out. So I'm factoring out the x. That leaves natural log 5 plus natural log 4. Over here, I've got natural log 4 minus. Now that 2 right there is in front. It's really the exponent on the 5. 5 squared is 25. All right, so I'm going to go ahead and write the 25 just to make stuff easier to punch in a second. One more. This next step is optional, but I think it really helps if you do it. My parentheses on the right-hand side has addition. Remember, when you do log addition, you really multiply. 5 times 4 is 20. Over here, I have subtraction. Subtraction means division, so it's really 4/25. So to solve for x, I'm doing natural log of 4/25 divided by natural log 20. And I'm just going to punch that in. And when I punch that in, I get negative 0.6117. And guys, you can check that on your test if you want to. You can plug it in both sides and see if you get the same thing when you plug that exponent in both sides. That's a doozy too. All right, make sure you can do that one, just saying. Okay, number 11, population growth of Mexico. And if you look at it real closely, I'll make this bigger for you. The formula is right here, and the formula will be on your test also. It is right there. I don't know how you can miss it. P of 0 means the population you start with. E is just the number E. R is the rate is growing, and T is time. Okay, so part A, no big deal at all in part A. It says in 2011, the population of Mexico was 113. That's PO. That's the population we're starting with. And the rate was, there's our rate, 1.1%. This is find the exponential growth function. So the function is this. P of t equals what we start with, 113.7, e to the rt power. E, the rate is 1.1%, which as a decimal looks like that. And you keep your t there. If you write the function, you keep the t in it. And then part B says estimate the population in 2016, which happens to be 5 years after 2011. So all I'm going to do is I'm going to do I'll put P of 5. 5 years later, it's 113.7 times E to the 0.011 times 5 in your exponent. Okay, I'm just going to, again, just punch that straight in your calculator. And when I punch it in, I'm getting 120.1. That'd be millions of people in Mexico in 2016. All right, expresses a sum or difference. Remember our rules here when we did log, when we started breaking up into pieces with logs. Anything multiplied was plus, anything divided was minus. In other words, anything on top in the numerator is going to have a positive sign. Anything in the denominator is going to have a minus sign in front. So it's going to look like this. It's going to be like log 4 plus log b minus, because now we're doing division, log 7 minus, because there's another 8 in there, a squared. Now the only thing you can do, do not leave any exponents in there. So I'm going to write one more line. The only thing I'm going to change in the second line is the exponent on the a goes in the front, and there it is. Right, that's all you gotta do. 13, tell if it's 1-to-1. Guys, it's 1-to-1 if it passes the horizontal line test. So all I'm gonna do is I'm gonna punch this graph right here into my calculator and look at it and see if it passes the horizontal line test. I'm punching right now. Now I'll say this, when you punch that in, you need to put the denominator in a parentheses. Anytime you have more than one number in your numerator or denominator and you're using your calculator, you need to put it in parentheses. I'm looking at the graph. It definitely passes it. So is it 1-to-1? Yes, it is, for sure. All right, last two, 14. 14 says determine whether -3 and also +2 are zeros. All you got to do there is synthetic. I'm going to put -3 in the box. See if I get 0 at the end. If I do, then it's a 0. If I don't, it's not. Bring down to 3. 3 times -3 is -9. Add them up. 3 times 4 is 12. Goes there. 6. So -3 is a yes, for sure. Now I'm going to try the 2. See what I get there. So I'll put the 2 in the box. I got 3, 5, -6, 18. Bring the 3 down. 3 times 2 is 6. That's 11. That's 22. There's no way. So that's a no. And as soon as you know it's a no, you can stop. But make sure that you know for sure. All right, the last one. 15. Find a polynomial of degree 3 with those zeros. All right, so write them as factors. So I'm going to take the 4, write x minus 4. The 3i, x minus 3i. The -3i, x plus 3i. All right, now if I were you, I would do the conjugates first. These second two are conjugates. Conjugates, remember, you can do foo. So if you do foo, you get first, last. Just like that. Now remember I squared. I squared is really -1, so it changes that 9 to +9. All right, I should be doing this too. I'm forgetting this. It says write a function. If it says write a function, you need to write equals f of x. Hint, hint. Don't forget to write equals f. I don't know what that was. Equals f of x. It's a terrible parentheses. Okay. Now to finish up, I'm just going to do FOIL here. First is x cubed. I'm going to go out of order. I'm going to say inside to get my x squared next. Going last. Sorry. Outer to get my 9x, and last to get my 36. There it is right there. All right, that's it. That's quite a video. Just like I say, just use it as much as you need to. Yeah, I don't know what to say really. If you need me, I'll be at school early Friday morning or during lunch, or I don't know exactly when your test is, but you can come see me. Please take advantage. Use the video. Do good. You've done good. You've had a great year. Finish strong. Miss you guys today. I'll see you tomorrow on test day.